Every single day, they're generating thousands of MRIs, X-rays, CT scans, you name it. And the sheer amount of data trapped inside all those images is just massive. It's gotten to the point where it's practically impossible for human doctors to process it all at the speed modern medicine actually demands. What if your doctor had a supercomputer for an assistant? Seriously, imagine an exhaustion-proof assistant, one that literally never sleeps, never gets eye strain, and pre-reads all this incredibly complex, multi-dimensional medical data before your doctor even steps into the room. According to some really exciting recent research, a deep learning architecture known as DarkNet-53 hit a 99.1% accuracy rate in classifying breast cancer using ultrasound images. I mean, wow. It's not just about doing things faster. We're talking about a level of precision that genuinely impacts patient survival. Now, let's be absolutely clear about what this is. This isn't some robot doctor rolling down the hallway to take over the whole hospital. Instead, it's better to think of deep learning as this invisible super assistant. It's a powerful, autonomous highlighter working quietly in the background to augment the human physician, basically flagging patterns that the human eye might, quite understandably, just miss. So what's the brain behind this whole operation? It's called a convolutional neural network, or a CNN. Now, in the past, analyzing an image meant relying on really slow, labor-intensive, handcrafted feature extraction. Well, CNNs totally bypass all that. They just look directly at the multidimensional data and autonomously learn all those complex features entirely on their own.
It's brilliant.
And this builds a completely streamlined workflow. Step 1, you input the raw medical data, usually a DICOM file, which packs in high-resolution images alongside the patient's metadata. Step 2, the CNN jumps in to do that autonomous feature extraction we just talked about. And finally, Step 3. It instantly spits out an actionable diagnosis prediction for the doctor to actually review. And the hard data absolutely backs this up. These deep learning models are performing exceptionally well across the most common daily imaging types. Just look at the remarkable performance with X-rays, towering at over 90% average accuracy. And it's closely followed by MRI and ultrasound. Let's dive into our first section, radiology and spotting the unseen. When you contrast the old way with the new, it's night and day. The traditional method is, frankly, incredibly labor-intensive, and because humans get tired, it's naturally prone to error. Deep learning changes the game completely with autonomous extraction and blazing fast speed. We're talking about instantly segmenting tumor margins to evaluate progression or rapidly detecting tiny pulmonary nodules in chest CT scans, which is absolutely critical for catching lung cancer early. Plus, these AI models are actively predicting complex, top 10 diagnosis and procedures directly from massive sets of clinical inputs. The AI is actually taking unstructured data and accurately mapping it right to standard medical codes with just incredible efficiency. Right alongside the imaging analysis, it's a real game changer. Moving on to Section 2, Pathology, Decoding the Cellular World. So the main challenge here is something called whole slide imaging, or WSI. Basically, these are extensive, high-resolution, digitized histopathology photographs, and they create massive, truly massive files. For a human pathologist to manually examine every single cell across that vast digital landscape, that's an overwhelmingly daunting task. But for deep learning, it's basically the perfect job. CNNs act as brilliant decision assistance instruments. They autonomously scan the entire whole slide image and spot malignant areas instantly. They can categorize prostate cancer severity right from biopsies and perfectly segment regions of interest in colorectal tumors. What used to take hours of tedious, exhausting searching gets compressed into seconds of focused, high-value review. Up next, Section 3, Seamless Integration into the Daily Routine. You might be wondering, how does this actually fit into a real hospital without totally disrupting the human element? Well, AI takes over the mundane stuff, things like basic picture annotation, and provides real-time diagnostic insights on the fly. It integrates seamlessly into the systems hospitals already use, like electronic health records and PACS. And newer vision language models are now literally linking a patient's visual X-ray directly with the doctor's written clinical notes for this comprehensive, instant overview. It frees up the specialist to tackle the really intricate cases. But here's the catch. Doctors have to actually trust the AI, right? Deep learning gets criticized a lot for being a black box. That brings us to a really crucial concept called Explainable AI, or XAI. It's all about turning that black box into a glass box. Using tools like GradCam, the AI can generate visual heat maps over the medical image itself. This way, the physician can see exactly why a prediction was made and what specific pixels drove that decision.
Finally, Section 4, Privacy and the Future, Protecting Patient Data.
Now, to train these incredibly smart models, you obviously need immense amounts of patient data, but you absolutely cannot violate privacy laws like GDPR or HIPAA. So what's the workaround? It's a brilliant solution called federated learning. Instead of centralizing everyone's sensitive data in one place, the AI model is sent out to individual institutions. It learns locally at each hospital and then only shares its newly learned parameters back to the global network. The raw, sensitive patient data never leaves the site. It stays securely locked down.
And that leads us to the ultimate conclusion from all this research. AI shouldn't supplant human knowledge. It should augment it. This technology is really just here to assist, because let's face it, AI isn't perfect. The human doctor remains firmly at the center of the process, making the final, most accurate diagnosis, just armed with the absolute best tools in history.
So, I want to leave you with this to ponder. How will an invisible AI assistant change your very next doctor's visit? Think about it. With better accuracy, faster results, and a lot more time for your doctor to actually sit down and speak with you, this behind-the-scenes workflow revolution is for sure going to directly impact all of our healthcare futures. Thanks for joining me for this explainer, and remember to keep questioning the world around you.